Let's go through leak number 60, permutation sequence. To give us an integer n and a k, let's find the case permutation. So this n is a number from 1 to 9. So we'll see there is from 1 to n, there are several permutations. For example, n equals 3. So the permutation can be 1, 2, 3, 1, 3, 2, 2, 1, 3, and there are 6 permutations. And we want to find the case permutation. For example, this k equals 3, that is 2, 1, 3. So for this question, actually, what we can do is that we know uh, it is like a tree structure, right? Um, so we'll see it will be n factorial for the total permutation numbers. So the first layer, this tree, it have n minus 1 factorial um, possibility, right? So this is n minus 1, right? This is n minus 1. So we know if this k is from 0 to n minus 1 case, right? This is k. Let's say this is 1 to n minus 1, right? Um, if we inclusive, then it falls into this tree. If we can change this k to be zero index, so we say if it is from 0 to n minus 1, it's in falling in this kind of subtree, and also if it is from n minus 1 to 2n minus 1, right? This is falling in the second subtree. So we just have this k, right, minus 1 change it to 0 index, and we just find the group size. This is n minus 1 factorial, and use this k to divide fa- by by um by the by the um subtree size, that is the block size, that's n minus 1 factorial. We um find the index, right? So the index will be from 0, 1 to something, right? Um, so if we find it in this subtree, right? So what we can do next, we just recursively do these things, right? We find that for this tree, the subtree will be n minus 2 factorial, right? And we find another branch until we find the last number. The things that we need to use use the array because, for example, this is we use this as 2, right? So in the subtrees we can only use 1, 3. So when we iterate what kind of subtree it is, we should skip this 2, right? Or 0 if we have a 0 index, 0, 1, we should skip index 2. So let's write code for this. We can use um we can pre-compute the factorial new int n, right? So what we do is that we're going to for int let's say f0 equals 1. So what we do is for int I equals 1, I smaller than n, I plus plus, we'll say the factorial I equals factorial I minus 1 multiplied by I, right? And as we talked about, we need a Boolean array called used equals new Boolean. And so, and we need a string builder. So what we are write is mm, We need a, let's also have a index, which will pointing to the factorial index, right? So that is every time we have move one layer up, down, right? We have index move decrease by one, so that we know the subtree size. So this is related to be the subtree size. So we're going to have int index equals n minus one, and we also have mm, I think that's enough, right? So let's say we have this one decreased by one. Then what we do is that while this kind of stream builder dot length is smaller than n, right? So we know the block size that equals factorial index, right? And so our um, group index will be k divided by size, right? And um, so we're going to have we want to find this will be the group index. So we'll write we can, because we want to append this I, right? This integer I will set I equals one for I smaller than, and we need to check the index, right? So if isn't used I, then we're going to have G minus minus one. So we'll write if G equals zero, right? Mm, then we just break. And when we coming out to this for loop, we just have string builder append this I. And also we need to have used I equals true, right? Mm, I think this have some problem. Uh, let's have let's do this. Let's have a count variable here. Count equals zero. Okay, and this will be let's instead we use stack index. Let's have the count group counts, right? So so in this case we'll have count plus plus. So I write um so we'll write if count equals this group plus count, right? We just break. Uh, and also we need this index to decrease by one, right? Because every time we go to the next layer, our subtree will be factorial the size. It is from n minus one, n minus two, so that will be I minus this index should decrease by one, right? So in the end, just return string builder to string. So this will be the code used. So this I is auto index. This should smaller equal to n, but this is the size will greater, right? Mm. The things that we should have this key, right? Every time we go to the next layer, we should have this one model equal to size. Right? So if we use the I, this have n plus one, okay. Doing like this, let's analysis the time complexity. So this length, we have one iterated length. And in each length, right, we also need to check for this n number whether they are used. There is another for loop, two for loops. So the time complexity O n square space is O n, right? Let's also write a Python code for this. So we are going to have f equals, let's see, this is for the factorial in f0 equals 1, right? For I in range from 1 to n, we're going to have fi equals fi minus 1 multiplied by n, right? So we're going to have used equals false multiplied by n plus 1. And the result, it's um, let's use this one, this list. So we're going to have we need our index for the factorial equals n minus 1. And let's change this one to be 1, to be 0 based, right? So while this kind of length result is smaller than n, so we're going to have size equals factorial index. And the group number, this is the one based equals k divided by size plus 1, right? And we're going to have k modeled by size, okay? So we're going to have a count variable equals 0 for I in range from 1 to n plus 1, right? So we'll say if not used I, then we'll have count should plus equal to 1. So we'll say if count equals group, we're going to have result append string I and used I equals true, right? And break. And this index should for the next length, right? Uh, for the next subtree, we should have the factorial index minus equal to 1. So in the end, just return this one for the join result. Trying to see. And small equal f index mod equal to size count for this one in if not used I. We should then count plus equal to 1. If count equals group break. Looks like we are always in ascending order. So we are trying to see the group equals this one. If count equals group equals k divided by size plus 1. And every time we minus equal to 1. So not used I. Not used I count should plus equal to 1. If this one, mm, and this one should divide multiplied by I, right?